Good morning. So in this video, we will see the thermal analysis of the composite wall. So this is the problem on the composite wall. So a composite wall is made up of three different materials. So first is conductivity K 2.76 watt per meter Kelvin. Second is 1.58 and third conductivity is 0.92. Okay. The dimensions for each wall is given. The left side of the wall has a temperature 200 and the right has a temperature 30 degrees Celsius. The question is we have to determine the temperature distribution through the wall. Okay. So in the ANSYS APTL, first we will model this and then we will apply the boundary condition. So go to the file, clear start new, then save the project, save as. Now select the preprocessor preferences. It is a thermal. Okay. Then preferences, element type, add element, add. Now here we'll do the analysis for composite wall by using a link element and select the 3D conduction. Okay. For the element type link, we need the real constant. So add. Okay, so basically the real constant is nothing but the cross section. So here, as the cross section is not given, so we will assume there is a cross section of 1 meter square. Okay, so 1 meter square means height is 1 and the width will be 1 meter only. Okay, so give here cross section as a 1 meter square. Okay, so add. Now the cross section area we will add as a 1 meter square. So it is the same. After real constant, we have to add the material property. So go to the material model, thermal, conductivity and isotropic. The first material is K 2.76. Okay. Then add the second material, new model, material ID 2. Okay. Isotropic. Second value is a 1.58. Okay. Again go to the material, new model, material ID 3. Okay. Again go to the isotropic. Value is a 0.92. So in this way we have added the three different elements. Now after the material property, go to the modeling, then create and select the key point in a active coordinate system. The first key point will be at 0, 0, 0. Okay. Again go to the key point, add the second point. Second point, you can see the thickness 20 centimeter. So select here 0.2, apply. Now third key point, so it is 0.5 plus 0.2, so it is 0.7. So this is 0.7, which is the third key point, apply. And the fourth key point, it is exactly at 1 meter distance, apply. Okay. Okay, so 30, 50 and 20 will be 1 meter. So in this way we have created the 4 key points. Now after key point, we need to create, as it is a link element, so we have to create the line. So go to the line and straight line. So select this. Okay. Now we have created the line through the key points. Now we have to apply the mesh attributes. So go to the meshing. First apply the mesh attribute. Select default attribute. Okay. Now here we have three different materials. So select the first. Cross section is the same. So just we have the one real constant. Okay. Select OK. Now go to the mesh tool. Go to the line set. Select the first. Go to the OK. And here we can give the number of divisions. If you want, you can give 10 division, 20 division. But I will just keep this as a 1, so that element will be easily visible. Okay. Again go to the erase hidden tab, mesh. Again select that line and apply the mesh. Okay. Just zoom out. Now again go to the mesh attribute. Select here second element. Okay. Again go to the mesh tool, go to the line. Now select this second, go to the OK and keep the number of division 1. OK. Erase the hidden tab, mesh, select this and OK. And the last, select the default attribute, select here third element. OK. Then go to the mesh tool, select the line, select this. OK. OK. Raise the hidden tab, apply the mesh. OK. Okay, now just check whether the mesh is applied. So go to the plot and select the multi-plot. You can see here ELKN means all the element, then lines, key points and the nodes, they are active. Okay, to visualize in a 3-dimension, go to the plot control, go to the style, size and shape. Just keep this display element on. Okay. Okay, now you can see here this is the first, this is second and this is the third. Okay, if you want in a 3-dimension, select here oblique view. So this is the view of that wall, composite wall. Okay, now here we have to apply the boundary conditions as a temperature. So go to the load, select the define load, go to the apply thermal temperature, and here we have to select the, either you can select on the line or key points. So just we have the line, so we can select the key point. Now select the left. Okay, apply the temperature, that temperature is at 200. Okay, again key point, select the right. Okay, that temperature is 30. Okay, now we have to solve this. Go to the solution, solve current ls. Okay, solution is done. Just check the result in the post processor. So select the plot result, contour plot, nodal solution. Just we need the temperature distribution, so go to the degree of freedom, nodal temperature, and OK. Now this is the temperature distribution. So from mean 30 degrees Celsius, left side has a maximum 200 degrees Celsius, and here you can see in between temperatures. If you want to see the result at different nodes, so you can go to the option result viewer. Okay, so there is a new tab will open. Now here you can choose the result items what you need. So right now we need the nodal temperature. Okay, and here go to the plot result. So you can see this how the temperature is varying from left to right. Okay, and if you want to list the result, there is an option list result. Okay, now here you can see node wise temperature. At the left, node 1 200, node 2 is a 182, node 3 107, and node 4 is a 30 degree. Okay, so if you want, you can take the screenshot of this temperature variation. Also, if you want to see the element, so there is an option view, then select the attribute. Okay, then what you need is a material number, just color and number. Okay, display of entity, node, element, key point, and replot.